So we have a quadratic equation because x is raised to the second power, just like Miss Watt has said. If we're asked to solve for it, what are we looking for? Mr. Monroy said x. We're looking for x? Well, we don't have, x is right here. I don't have to look for it, it's right there. There's x too. So if you're asked to solve the equation, can you get to the heart of what does that mean? Solve an equation. What the heck does that mean? We got a quadratic. Break it down. What do you mean by break it down? Let's get to what that means. Extra credit if you finish all that by the time I'm done.
This little piece?
Watch this.
This
So,
little piece?
is there any more in the bag?
Yeah.
Yeah, if you finish all of it, I'll give you extra stamps.
Okay, go.
All right, ready?
Set,
So,
go.
wow.
Who's that
That's pretty
star?
impressive. I don't want ants, please, or rodents. So we're going to break down the trinomial. The way we break it down is by factoring that puppy into two binomials. All right? This was the last lesson of the quarter. Okay, so we're going to factor the trinomial. So let's factor it. Here we go. I need two numbers here and here that become the ax squared, the 3x squared. The only possibilities are 3x and x. There's no other possibility. No other factors of 3 besides 3 and 1. Then I need two numbers that multiply to become the 2. I'll try a plus 2 and a plus 1 to see if that works. So we'll try the outsides and insides now, right? Outsides, insides. 3x times 1 is 3x. 2 times x is 2x. Add those puppies up. Okay, if I add up these two, 5x. And that's exactly what we wanted. Alright, so we factored it correctly. But let's not get all happy, because we haven't solved it yet. All we've done is factored the trinomial. I don't know what numbers satisfy it yet. All I've done is I've taken this trinomial into two binomials. I've rewritten the expression into two binomials. We haven't solved anything yet. Do you remember the last move that I taught you yesterday? Rico, what did I do?
You grab the numbers in the binomial and you color. Or you put 3x plus 2 equals 0.
Right, so what you want to say is set each binomial. How many binomials I have here, Badagan?
One.
There's one binomial here? Look at right here. How many binomials do you see?
2.
There's two of them. I'm going to set each one of them equal to 0. And that'll result in both of my solutions. Watch. Monroe, you with me? 3x plus 2 equals 0. That's going to be one solution. And I'll put a big fat and symbol. X plus 1 equals 0. Right? So let's do it. Notice I have two simple one-step equations, or very simple equations. I'm going to isolate x here, and I'll isolate x here, and those will be my two solutions. So let's isolate x here. Let's get x by itself here. So I'll subtract 2 from both sides. Subtract 2 from here and here. So I have 3x equals 0 minus 2 is negative 2. X is still not by itself, though. I have to divide by 3. This is why you took math 1 before you math 2. You got to know how to solve a simple equation like this. So x is equal to negative 2/3. There's one solution. So this is a solution. But we have another one. Look at the and symbol. let's get x by itself here. We'll subtract 1 from both sides. X is negative 1. That's also a solution. Notice. Do you see it? Okay. We're done. But what I want to do now, just for the sake of tomorrow's exam, tomorrow I'm going to just throw 2 equations at you and ask you to solve them, and you'll just do what I just did. But I'm going to ask you to also verify that the solutions are satisfied. So what I'm going to do, I'm going to verify that negative 2/3 and negative 1 are actually solutions. Let me verify. So let me verify now. Watch. Let me rewrite the equation. 3x squared plus 5x plus 2. Let's verify that negative 2/3 is a solution. Wherever I see x, I'm going to replace with negative 2/3. I'm worried about you. Your eyes are all over the place. And it's 4th quarter in a football game. It's 9th inning in the baseball game. It's 18th hole in golf. 3rd period in hockey. 15th round in boxing. This is it. Any sports on? Extra 2 minutes in soccer. Any other sports? 9th inning baseball. Oh, yeah, fourth quarter basketball. This is it, Monroy. Don't get balled up. Here we go. I'm going to replace x with negative 2/3. Square plus 5 times negative 2/3. Plus 2 is 0. This better be equal to 0 or we did something wrong. I'm verifying that. By the way, on tomorrow's test, I'm not going to put a fraction because then I'll get people all stressed out on Friday. Yeah, so no fractions, so no stress. You plan on showing up tomorrow, nurse? Final? Basket, you gonna show up for the final one? You thought about it, Dean. Thank you for taking time to think about it. She's already like this before you even finish the question. Alright, let's do it. So, exponents first. Negative 2/3 to the 2nd power. That's negative 2/3 times itself. That becomes 4/9. Look at this. Exponents first. Times 3. Sweet. 3 times 4/9, what? Let me make this into fraction. 3 times 4 is 12. This is really 12/9, yeah? 1 times 9 is 9. Plus, make 5 into fraction. It's going to be negative 10/3. Plus 2 is 0. (12/9) plus negative 10/3. I can't add fractions unless I have common denominator, so I'm going to make the 3 into a 9, so I'm going to multiply this by 3 over 3. So I got negative 30/3 here, 12/9 here. So now, wait. Negative 30/9. Because denominator 3 times 3 is 9 here. So I have common denominators now. Now I'm ready to rock and roll. 12 plus negative 30 is going to be a negative 18/9. Plus 2 is 0. Negative 18 divided by 9 is a negative 2. Plus 2 is 0. Negative 2 plus 2 is 0. Look at it. It's a true statement. It satisfies. Negative 2/3 satisfied. Let me verify now that, what was the other solution? Negative 2/3, what was the other one? What was our other solution? Anybody?
Negative 1.
Negative 1. Let me verify that negative 1 works. (3x squared plus 5x plus 2) All right. Wherever I see x, I'll replace with -1. Ready? Exponent first, so -1 times -1, that'll be +1. -5 plus 2 is 0. So 3 times 1 is 3, plus -5 plus 2 is 0. It's going to be a -2 plus 2 is 0. I got a 0 equals 0, satisfies. So both solutions are proven to satisfy the original equation. Got it? So that's how we solve quadratics. Now there's other ways to solve quadratic equations, but we ran out of time in this quarter. So all I'm going to hold you on tomorrow's final is just to solve a quadratic equation by factoring the way I just showed you here. I'm just going to throw 2 equations at you. Should take you 5 minutes to do the final. I'll grade it on the spot, give you your final grade, and you go into the summer with a big fat smile on your face, or into 1 week till I see you guys for summer school. Was it June 2nd? Wednesday? Yeah. Me and Killinger will be holding down the fort. It's gonna be fun though. So I'm done teaching. I'm done.